At the dawn of the internet, IP addresses were abundant. Billions, in fact. A web server could be brought online with one IP address and it would serve one website. Easy. It was a problem, though, and we saw it coming very early on. It wasn't as easy as the nascent internet seemed. We had too many devices, and more coming online every day. One way to combat this was to stop IP address waste by not giving out massive blocks of IP addresses that were used inefficiently and ultimately hoarded. So we got rid of the classful allocation system we'd been using since the early 90s and kept some sets of IP addresses in reserve. Even still, the 4 billion IP addresses we had mathematically allotted to ourselves, 32 bits only goes so far, were still running out, and there was no way around it. IPv6 was an answer, but its adoption was sluggish in the best of times. And if you look hard enough, you can see that it exists. It's being used, but it's far from everywhere, and it was proposed in 1995. There were other answers too, like private IP addressing and network address translation, two things that everybody at home uses behind the scenes. On the server side, there was virtual web hosting. In short, it allows one physical server on one IP address to host many websites as opposed to just serving one. It's about efficiency. But back then, things were simpler to configure. The popular web servers like Apache, IIS, and soon tons of web hosters were doing it. Remember, it's about efficiency. What this means in practice is that website1.com and website2.com could end up pointing to the same IP address. To make all this work, the name of the website was sent along with the HTTP request, which let the server, through the magic of HTTP 1.1, get the user to the right website. This was great up until HTTPS, the secure bigger brother to HTTP, started to really make headway. Formally specified in 2000 with RFC 2818, it slowly grew in popularity over the next decade. Now, all this encryption, the secure part, is good, but the question arose very early. How do you know which site you're trying to connect to when multiple websites live at the same IP address? Because that information in HTTP 1.1 was stored in the part of the handshake that's now encrypted. Enter server name indication in 2003. With this addition to the encryption specification, the website's name was now stored in the front-loaded but unencrypted part of the handshake called the Client Hello. This meant that servers hosting many websites on a single IP that came into contact with this information could route traffic to the correct website. Firefox and Internet Explorer started supporting this in 2006. And Chrome followed after in 2010. Hooray! It's all solved. Except that it most certainly wasn't. With the rise of advertising and, more importantly, tracking, beginning well before HTTPS ever even got the slightest foothold, SNI would be a huge help to those wanting to see where you're going. That includes your internet and mobile service provider and web hosting services whose IP addresses you're interacting with, and anybody with access to the handshake in between. Snoopers and trackers would hardly be deterred by any of this because, remember, the client hello comes before the actual encryption and contains a request for a specific site's certificate. So, of course, the obvious answer is that we have to encrypt the SNI, or the part of the client hello request that contains the server name you want to talk to. But this part wasn't encrypted before specifically because servers needed a way to read the data without decrypting, since there was no way to trade keys prior to the handshake that contained the name of the server. What a conundrum. We had to enlist the help of public key cryptography, the same type extra big nerds like me and Dan would use to encrypt an email with GPG, and DNS here. So now, with encrypted SNI, when a DNS server is queried for a server name, the IP address along with the server's public key is sent instead of just the IP address. This allows the user to encrypt the server name before sending. What a great solution! Except it wasn't. It was a stopgap. And more HTTPS was coming. 80% by the year 2020, by the way. All so that we could eventually have ECH, or Encrypted Client Hello, that encrypts the entire handshake, whether or not all of the data is sensitive. Aside from the server name being in the clear before encrypted SNI, the ALPN, or Application Layer Protocol Negotiation, was in the clear too. This allowed snoopers to see what type of protocol you were speaking, like email, IRC, or any other number of to-be-encrypted protocols. With ECH, though, there are two parts, the inner and outer SNI, with the outer having non-personal information in it, but only enough to facilitate encryption of the inner portion that contains the server name, the protocols, and the other fancy bits. So that brings us to where we are today. Firefox 118 and better in 119 support this. I believe Chrome 115 supports ECH. So now we're in a much better spot with being a secure requester of information. And I mean, I know that whole entire history was just for funsies, but this really does confer a whole lot of privacy on you.
This is good stuff. Yes. Pay attention to the previous history. This is really, really good stuff.
For me and you.
Mm-hmm.
But for large enterprises that use SNI and ALPN to do traffic shaping and blocking, this is going to be a real problem.
Probably.
Yep, it definitely is, because where people could look in.
Yeah, they can't see that application layer stuff that's happening to be able to analyze those things and know what that fingerprint is to be able to shape the traffic and whatnot. Yeah.
There are entire multi-thousand, if not $1,000,000 devices that use ALPN to do traffic shaping and blocking.
I know.
And you know, there are tons of, you know, small time filters, even, you know, that you and I might use for free at home that use SNI to do blocking for domains and things like that exist, you know, only on Cloudflare or, you know, only behind the one IP address that hosts 600 websites. It is great from a privacy perspective, and I absolutely love it. But there are downsides to this, and there are going to be a whole lot of people that pay a whole lot of money that are going to be real unhappy with the state of the internet in a little bit.
The far end has to obviously support that too. So I mean, So I mean, a lot of the corporate things, they're going to take a while to catch up, because that's kind of the way corporate stuff works.
Of course. So, but like I mentioned in the history, we're talking 2022 actually saw the highest at like 83-84% of HTTPS requests over HTTP, which is funny because it kind of petered out there and dipped ever so slightly, still above 80%, but ever so slightly. And in 2022 and now into 2023, we're still looking at approximately 80%. Yeah. So it seems like 80% is going to be about as good as we're going to get.
Maybe. But like, so here's the other thing with Firefox. Obviously, 119's got some improvements in this. In it, you know, they made some enhancements there, which I just upgraded to today, just for funsies. But
you better believe it. You know what it's not in? Most everybody's repository as we record this, but as you hear this, it will definitely
be there by then. Yeah,
so
for sure.
It's Tuesday today, everybody.
Right. Yeah. So here's the other thing. You know, the DNS over HTTPS kind of helps you with some of this, but you don't have to use that. Like, so some people, for obvious reasons, want to be able to split their DNS traffic. Especially if you're running like you and I probably are. I mean, I've got Pi-hole running here in the house, and I'd rather my traffic go through Pi-hole, for
of course,
you know, because, you know, then I can have a little more control on it. And so, you can still take part in this, which is the great thing. You don't have to, it's not an all or nothing sort of deal. You don't have to use DOH to be able to, get the features here.
I think that's the really cool thing. You just update your browser, and the websites that support ECH are just going to now give you additional protection. I think that's really cool about the web in general. I think this is how the HTTPS rollout was.
Yeah.
Let's Encrypt happened in 2016 and just skyrocketed the amount of traffic that is now encrypted.
Right.
Whether or not that's a good thing, right? Like we were talking about, I think maybe it was on the last live stream.
I think generally speaking, if left to their own devices, a lot of people wouldn't probably bother with securing things, and encryption does secure things, and so then you get lazy with the data that you're sharing, potentially, and so then it's just out there in the clear, and that's not good. It's probably good to put some guardrails on things so that people don't make accidental whoopsie doodles. And so like at least your traffic's encrypted in transit. You have a man in the middle sort of thing feeding you, like pulling it in and then manipulating, AI there, manipulating it and sending you some other subliminal message.
Doing the digging on this, Cloudflare has changed what M stands for, but not the meaning.
Right.
M stands for monster.
Monster in the middle.
Monster in the middle.
That's appropriate for spooky month now, isn't it?
It kind of is, isn't it? Yeah, the monster in the middle. The monster
Yeah.
Well, that's Google, but...
Well, I mean, I guess, is Cloudflare, kind of some of that too? I mean, you got a lot of different things that they're caching and delivering.
You better believe they're in front of more than half of the websites that you visit on a very regular basis. Yeah, and in some ways, I suppose you could make the argument.
I guess, spoiler alert, I've got some Cloudflare tunnel action stuff happening here for things that Leo and I use.
Yup.
So, but it works, like, in a way, right? I don't know.
Mm-hmm.
Yeah.
Well, we haven't been DDoSed yet. That's not an invitation to do so. But,
please not.
So I think this is great. I do think ECH is great. I think ESNI and SNI before it. Well, not SNI, I guess. I mean, it worked and it saved people a whole lot of CPU cycles.
More complete package. Yeah.
Right. Yeah, ECH was always where we wanted to be, which is encrypt absolutely everything that could identify or help track or help pinpoint anybody.
Yeah, this is honestly probably the more critical part of the conversation to be encrypting.
Yeah. Yes. Right, because prior to this, if the domain name that you were going to was exposed, that's bad enough. Just knowing where you're going already proves at least a little bit of intent.
Yep.
Right? I mean, I suppose everybody could imagine a website that they would go to right now there's only one thing you do at a website like that. Do you want everybody knowing that you go to a website like that? Whatever website that is.
Yeah.
And
I don't know.
This is where ECH is going to help you
that's
out.
That's linuxuserspace.show/onlyfans, right?
Don't tell anybody you go to that website. You just click on the Patreon button and hook it up.
All right. Yeah, fair enough.